recognize that words or those words. Greatest, what does greatest mean? Biggest, best, the highest. Common would mean something that you share. All right, when we talk about what people have in common, it's a characteristic, a trait that they have in common. And then factors are two numbers that multiply together to give us our product. So we would say 3 and 4 are factors of 12. I think of it more as what numbers divide into 12. The numbers that divide into 12 are the factors of 12, but it's also the things that multiply to give us a given product. So we're going to be taking a look at algebraic polynomials, looking at those polynomials that you've been multiplying already. So a lot of it's going to be looking at the answers and trying to get back to the original question. So let's take a look at what we need to do. Describe what a factor is. Well, I kind of already gave you guys a little bit of a heads up. So what definition can we put here? What is a factor? What can we put there?
Two numbers that multiply together.
Yep. Two numbers. For a given product. Now what we're going to keep in mind, ladies and gentlemen, is that they are going to be positive and they're going to be whole numbers. So what I mean by that is, you say, okay, what are the factors of 7? Well, 1 times 7 gives us 7, correct? But we can't use 2 times 3.5. Even though 2 times 3.5 will give you 7, right, guys? You type into your calculator 2 times 3.5 will give you 7? Yeah, but we're only interested in positive whole numbers. The same thing if I asked you, for the factors of 15, you're not going to tell me -3 and -5. You would just tell me the positive 3 and the positive 5. Okay, guys, so we don't have to worry about positive values and whole numbers. And so the greatest common factor, okay. So describe what a greatest common factor is. It's the largest factor Did you need something from me? Because it's SSI. Okay. Thank you for remembering. The largest factor that two values, I don't want to use values. Let's use terms. Let's start using that two terms have in common. I hesitate to use the word common there, guys, because we don't always like to use one of the words in the definition. So it's two factors that they have the same. All right, so we need to have some strategies for finding greatest common factors. Is anyone still ready? So we need to find the greatest common factor. And we're just going to start by using some whole numbers, because we are going to be looking at whole numbers. We're going to look at the coefficient of the term for this given number. So 42 and 60, how are we going to find the greatest common factor of 42 and 60? What strategies do you guys use for that? You guys have a strategy? All right, it's your lucky day, because you're going to get one from me. Ladies and gentlemen, I start with the smallest number. And it may seem silly because I want to find the greatest common factor, but dude, can anything larger than 42 divide into 42? No. So I'm going to check and see if 60 works, because 60 never divides into 42. So the largest common factor they could have is this smallest number. So I start with 42. Does 42 divide into 60? Eli's shaking his head no. Someone said yeah. If you're not sure, ladies and gentlemen, how are you going to test this? On your calculator. So you get those calculators out. Some of you like to warm seats for us. Not today. What? We're just going to do in-class quiz fixes and some problems on the board, so it's just working class together. Okay. These are separating them so you can. All right, so 42 and 60, ladies and gentlemen. Did 42 divide into 60? No. So now what I need to do is find the next largest number that might divide into that. Well, I don't want to leave anything out, guys, so here's where I have to actually list factors. So I start with 1 and 42, because 1 times 42 is 42, correct? I then go to 2. Does 2 divide into 42?
Yeah.
21 times. Does 3 divide into 42? How many times? 14. Does 4 divide into 42? I can stop there and I know no. I didn't even have to wait for you guys to check for me. Why? So you want to know why I knew no to the 42 so quickly, but I had to hesitate with the 3? Because 4 times, what's 4 times 10, guys? 40. And if I do 4 times 11, what am I going to be at? 44. So I knew I was going to jump over 42. Just because I knew my 4s well enough there. What about 5? That should be an automatic no. Why are we not even testing 5 on our calculator, Morgan Murphy? How do I know it doesn't divide by 5? Because it's even. Well, not because it's even, because it's a 2. What's the only thing that 5 is going to divide into? 0 and 5. Good job. What about 6? Does 6 divide in there? And I'm done. I don't have to try. I don't have to look for any more factors, ladies and gentlemen, because what's the number after 6? 7. And is 7 already in my list? So you've listed them all. Ladies and gentlemen, I know some of you are like, I already found this weird and I didn't list them. All right. Good for you. You're going to have to do this in a couple of, probably 2 days from now, next week. You're going to start listing those factors. So today on this greatest common factor worksheet, in these notes, you're going to practice listing those common factors. That's one of the biggest starts to these problems that we're going to have here in chapter 10 coming up, is being able to list all the factors of a number and having a routine to it. I started at 1, and then I went to 2, 3, 4, 5. We don't want to leave anything out, ladies and gentlemen. Nothing's more frustrating for a student than when Mr. Clement and I come around and go, well, what about 5 times 6? Oh, you're right, that multiplies to give me 30. All right, so take the time to list all of those factors. So now that I have all these factors of 42, how am I going to find the greatest common factor between 42 and 60? What strategies could we use there? I've listed all my factors out. How am I going to find that largest common factor? We could do the same thing with 60, except I could end up listing a lot of factors. What I'm going to do is I'm going to do 60 divided by 21. Does 21 divide into 60? No. Does 14 divide into 60? You either know yes or no, guys, or how are you checking that? On your calculator. Does 7 divide into 60? You don't know? You don't know that 7 times 9 is 63? And 8 times 7 is 56, then you're going to divide that out on your calculator. Does 6 divide into 60?
Yeah.
That's my greatest common factor.
You notice, hopefully all of you saw that she went from the largest number in that list around, all right, to 6. Not across the 1 and 42, then the 2 and 21. Some of you will pick 2 without even looking at the 6 in that list. All right, so go largest numbers around. It doesn't go into 60.
Okay. So ladies and gentlemen, we talked about being organized in math, and that's where being a very left-brain person, which is your kind of like those people who are organized, helps me in math. Those of you who are my right brain, my artistic people, we're not always organized. But the more you can put yourself on track to writing those things down neatly in order, and I go from, notice when I start with 1, don't I end up with my largest factor over here? And then I went with 2. Did my next largest factor end up below it? So when I go in order like that, guys, listing those factors, I'm able to then make sure, like Mr. Clem said, start at the top and then work your way around, and you're always going to find the largest one. So I want you guys to use this strategy, a good strategy, for finding the greatest common factor of 36 and 64. So did you do 64 divided by 36? Did you do 64 divided by 18? Did you do 64 divided by 12? Or did you do 64 divided by 9? Oh, and you asked for it up there. All right, you got, how did you get 4?
I just don't know yet.
Raise your hand if you have questions. Start.
So why did you start at 10? What if it was 12? What if it was 12? Because sometimes your guys' common factor is 12. Okay, I want you to list factors, like you did there. That's what I want. Because you're spending a lot of time dividing both those numbers by 9, by 8, by 7. You shouldn't have to. If I find the factors of 36, then I'm not dividing random numbers into 48. And I want you to get in the habit of listing these factors because you need that for the next lesson that we're going to do after this. All right, so it'll be fine. You got all the factors written down? Good job. So let's find our answer. I see a lot of factors written down. Now, why are we listing the factors of 64? What are you going to do with those? Well, then tell me what I did here. I listed the factors of 42. Did I list the factors of 60? But how did I find 6 as the greatest common factor?
6 times.
I said 42 divided into 60 is 42. No, did 21 divided into 60. So I didn't have to list the factors of 60, which could create me another long list of them. I started with these factors and divided them into 60. You're going to start with your factors of 36, Corey, and divide those into 60. That way you get a smaller set of numbers that you're working with. Okay, I think you missed a factor. You missed one factor for 36. Start there. You're missing one factor of 36. 6 times 6 is 36. Alright, I don't know that. So I don't know that. So then what are you doing? So you write 18 with 1 over. You just all of them. Yeah. So that's why having that very question. Alright, now you have your list. What did I do once I wrote my list? Do you remember? I wrote my list, and what was the first question we asked you? We said, is 42 divided into 60? Is it a factor of 60? Is 21 a factor of 60? So we're checking to see which of these divides into 60. So you're going to take your factors of 36 and see which ones divide into 64. You were not taking that in my class. No way, Jose.
No.
Oh, thank goodness. So what do you find? So how do you get 60? I don't believe it.
No, I didn't. Oh, wait. It was
You only want to try these.
Well, so this is what I did.
So you don't get your answer. It has to be the factor that was on the Now I see what you have 60. All right, Mr. Clark, we got a lot of good answers out there?
Yep.
Ladies and gentlemen, how many people got 7? Good, I'm glad no one got 7. How many people got 2?
2?
How many people got 4? Excellent, excellent. No hand from Marissa, but Marissa, I'm pretty confident you got 4, right? All right, so what are the factors of 24? Brielle, what would be the first pair we would write down? 1 and 24, let's get that written down. Haley Pierce, what would be my next pair of factors for 24? Okay, Corey, what's up? 2 and 12. The next thing we're going to check is 3. Does 3 divide into 24?
Yes.
How many times? 8 times. Does 4 divide into 24?
6.
Does 5 divide into 24? Does 6 divide into 24? I already have my list, so I'm done. That's what it means to list the factors of 24. get in that habit of writing this down. I start at 1 and work my way forward until boom. I'm back to repeats. So now we gotta find what divides into 81. But the cool thing is, guys, is you're only gonna try at most 8 numbers. 8. That's the most you have to try. Well, because how many numbers do we write up here? 8. And those are the only 8 you have to try. Don't try 21. Don't try 9. Even though 9 divides into 81, why am I not trying 9? Because it's not on the list of 24. That's about having a smart student. Stick to your list. So you got an answer? Did you find it? Nice. Is that strategy working for you? Good.
You having fun?
I am, but now I'm looking at my time. All right, ladies and gentlemen, how many people got 12? No takers on 12? How about 3? Excellent, excellent. All right, so ladies and gentlemen, what's different between this group and the previous group? These, okay, Lucas described these as looking harder. How many people would agree that's the way to describe them? They look a little bit harder. I think Jackson added something in that I like in how they're different, not just hard, because we call all math hard. How are these different, Jackson?
They have exponents.
They have variables and exponents. So ladies and gentlemen, we're going to treat 32 and 48 the same way we did before. We get to ignore the x's, we get to ignore the p's, we get to ignore the t's. So we're going to find the greatest common factor of 32 and 48 the same way we did before. 1 and 32, 2 and 16, 3 does not go into 32, 4 and 8, 5 does not go into 32, 6 does not, 7 does not, 8's up on the board. So how many numbers am I going to check in 48? 6 at the most. Does anyone know which of these divides into 48 off the top of their head? 8 does? Check the 16. Does 16 divide in there? Because I was going to go with 16, but I know right now. 16. So please be careful, guys. I do choose that example. Mrs. Carlisle, she teaches at the middle school now. Her and I sat down a number of years ago and were real particular on how we pick some of these examples here. Because something like that, we a lot of times see students want to go with 4 or 8. And we've got to make sure we're trying those large numbers. Mr. Clump's kind of shaking his head there. We're seeing that with our juniors right now. So make sure you're listening them out. So we're going to write a greatest common factor for the coefficients, the 16. Now I'm going to look at my variables. All right? How many x's does x to the third have? 3. So I can list the factors of x to the third as x times x times x. How would I list the factors of x to the fourth? X times x times x times x. So what do those two groups have in common? They both have x's. How many x's do they have in common? 3. I've got, well, 7 total, right? But this group has 3. And this group has 3. So for my variable, ladies and gentlemen, I'm going to write my greatest common factor as x to the third. It really isn't that much harder because we're going to start to see some patterns here. All right, 18 and 48, the greatest common factor there, I'm going to have to list out these 18s. 1 and 18, 2 and 9, 3 and 6, 7 doesn't work. 8 doesn't work. And 9's already up there, right there. 4 and 5 don't work. 6 is up there. All right. Did I skip over anything, guys? Those look complete. All right. Does 18 divide into 48? No. Does 9 divide into 48? Does 6 divide into 48? All right. So we have 6 as our greatest common factor. Now let's think about these p's. How many p's does p to the 5th have? 5. How many p's does p to the 1st have?
1.
So it just be p.
Has 1 p, right? So how many p's do those two have in common? 1. So it's just 6p. I want you guys to try number 3 on your own.
Oh.
But 8 doesn't divide into 18. So that's why I always start with this in the factors of 18. Because if I start with a larger number, sometimes I find much that that divides into its own. Let's look at, what are the factors of 13, ladies and gentlemen? 1 and 13. Does anyone know what we call a number like that that only has those two factors? Prime numbers. What do you say? A loner. Okay.
Unlucky?
We like prime numbers. We like prime numbers a lot. Does 13 divide into 52? So our greatest common factor is, for the coefficients, is 13. Melissa, how many t's do those two have in common? 1. Ladies and gentlemen, did any of you notice that each time our greatest common factor for the variables was just that smallest exponent? Let's take a look. Here we had x to the third as our greatest common factor. Was that my smallest exponent? Yeah. Here I had p. Was p to the first my smallest exponent? And the same with t. You can still write them out, ladies and gentlemen, to count them up and see what they have in common. But for your variables, it's always going to be that smallest exponent. All right. So now what we're going to do, ladies and gentlemen, is work on what's called factoring polynomials. All right. Another way of calling factoring is to undo the distribution. So we did some distributing today in our warm-up. And so what we're going to be looking to do is to go back to what number was out front and getting distributed to that binomial. These are all binomials, so it's going to be distributed into a binomial. So I'm going to do the same thing that I was doing above in the previous examples. The only difference is instead of having a comma between my two terms, what do I have between them? A plus. I'm still going to look at 4 and 16. What's the greatest common factor of 4 and 16?
4.
Quite a few of you knew 4. If you need to just double check, we've got options of 1 and 4, 2 and 2, but 4 does divide in there. Now, what about your D? How many D's does this first one have? 2. How many D's does this one have? None. Do they have any D's in common? No. So that means you can't put a D out there as your greatest common factor, ladies and gentlemen. If there's no D's that they have in common, then I can't list it. So now what you're going to do is undistribute. Another word for that undoing distribution, ladies and gentlemen, is I simply call it dividing by your GCF. I'll tell my students a lot of times, divide. What's 4 divided by 4? 1. And so that's going to leave you with 1 d squared, d to the second. What's 16 divided by 4? So if we take this across the hallway and give it to Mr. Lett's third hour class, tell them to solve this problem for us, what would they do? We gave them this. What would they do? They would distribute. So they would do 4 times 1d squared. What is 4 times 1d squared? 4d squared. What's 4 times 4? Ladies and gentlemen, did we get the same answer to the problem you were given? And that's what your goal is. Oh, I did not want to extend that page. Your goal is to get the original problem when you multiply it out. All right, let's take a look at number 2. 14x to the third minus 2x. All right. Smallest number is 2, correct? What's the greatest common factor of 14 and 2? 2. All right, my x's, I've got 3 of them here. I've got 1 here. So what's going to be my greatest common factor for those two? 1x. Beautiful. Ooh. Jackson said 7. Where is he getting 7 from?
I was just listening about that before.
The 14 divided by 2 is 7. I like the 7. He said it. I knew it was a good number we were going to need. He was just kind of on the already undistributing list. But it can't just be 7, ladies and gentlemen. I've got to have some variable here, correct? I just heard someone say x to the second. Why, Eli? Ladies and gentlemen, I only have 3. We took out one of those. We factored it out. We have x squared. The other question I asked myself is, what do I have to multiply x by to get it up to x to the third? I would need 2 more x's. All right? So there's one way to think of it. As Eli said, is subtracting it. The other thing is to think of, what do I have to add on to 1 to get up to 3? All right, we're going to divide. What's 2 divided by 2? 1. And if we have 1x here, but we factored it out and put it there, there are going to be any x's left here? No. So this is our final answer. Ladies and gentlemen, I want you to try 3 and 4 at your seats. Yes, there's 1 and 5. Good. Alright, so ladies and gentlemen, alright, I'm hearing some talking, I'm hearing some discussions. Any questions that we can ask out loud? Nikki? No. Is there anything that you guys, I think there's some questions we need to ask out loud. I'm hearing people say the number 1. Ladies and gentlemen, that's a 1 in front of that x squared, correct? So what's going to be the greatest common factor of 1 and 5? 1. Well, you start with the smallest number. What are the factors of 1? 1 and 1. So that means the only thing you can have here is a 1 is your greatest common factor. But what about your x's? What's going to be the greatest common factor between x squared and x? 1x. What do you have to multiply x by to get x squared, guys? What's going to go here? X. What do I have to multiply 1x by to get 5x? Just 5. I think of factoring, guys, as pulling something out. So I'm pulling out a 1 and an x. X squared is 2 x's. I'm pulling one of them out, so that leaves me with 1x. Here I had 1x. I'm pulling it out, and so that leaves me with no x's there. All right, 30 and 17. What was the greatest common factor between those two again? Just 1. Now, what about for x to the 4th and x squared? And I heard 2 x's, so we're going to write that as x squared, right, guys? All right, so what's 30 divided by 1? 30, that's not going to change. This is x to the 4th. You're pulling out x squared. That means you had 4, and you're pulling out 2 of them. How many does that leave me with? So I'm going to write it as x squared. Beautiful. Last term. Cody said 17. Are there any x's that have to go with it? Why?
Because you took 2 away.
There were 2 of them there. I took 2 of them out. Beautiful. Remember, guys, you can always double check.
The question came up, do you want, like, when they have their assignments?
Tonight, because you only have 12 problems to do that with, I want you to, or not even 12, you have 6 problems to do that with. I want to see your checks. All right? So your assignment for tonight, ladies and gentlemen, The top two, the top six, please listen. You're only, no, Mr. Klein's going to put missing assignment reports by you, but please, eyes up front right now. Here you're just finding the greatest common factor. Here is where you're doing the factoring, so these are the ones where you have to do the dividing. Okay, guys? So here you have to divide. This is where you need to check. And look how there's a big section of space down here at the bottom of the paper. You've got plenty of room for checking. All right? You are so welcome.